lot of the work that I've done around the social determinants of health. Specifically, I'm going to be talking about the analyses that we've done for a cohort study that's called The Mechanisms Underlying Stress and Emotions in African American Women's Health. So this is a study, an NIH-sponsored R01 cohort study under the direction of Dr. Tanae Lewis, who's an social epidemiologist here at Rollins School of Public Health. The kind of overarching motivation for this study is essentially that the cardiovascular disease rates, and so when I say cardiovascular disease, that's stroke, heart disease, these rates are higher in African Americans compared to other races throughout the country. And specifically, African Americans are the only group for whom gender does not confer some protective status. So for most groups, women have lower CVD rates than men, but this is not true for African Americans. And a lot of work has essentially shown that the early middle age is the key stage of life where this risk accelerates for African American women. And unfortunately, a lot of work has been done around trying to tease out what are some of the perhaps causal factors, or at least correlates of this increased risk. And the traditional risk factors that most people think of simply don't seem to point to don't account for the disparities. So traditional things like diet, exercise, even socioeconomic status don't really seem to have the same differential effect for African American women compared to other races and ethnicities. So this study follows a cohort of about 422 women. They were all between the ages of 30 and 45 at initial enrollment, and it was intended to have annual follow-ups. We only included women who were premenopausal and had at least one intact ovary, and excluded women who performed overnight or shift work, had previous history of cardiovascular disease, or had other comorbidities that could be associated with cardiovascular disease. So one of the reasons that we use ambulatory blood pressure in this study is blood pressure is, first of all, known to be one of the kind of easiest to attain indicators for increased risk of cardiovascular disease. And this is used both in clinical settings and in research settings. We also know that blood pressure is responsive to psychosocial stressors, right? So this could be depression, anxiety, stressful experiences. It's also responsive to kind of environmental stressors or environmental factors in general. So whether you're hot or cold, standing or seated, active or inactive, blood pressure is responsive to environmental stressors. We also know that blood pressure tends to follow a circadian rhythm that is expected to decrease while asleep. As I just said before, blood pressure is responsive to environmental factors, so that includes activity or rest, or I guess internal factors as well. And a lot of work has shown that elevated nighttime blood pressure and a lack of decrease from daytime to nighttime blood pressure are associated with increased rates of cardiovascular disease. Now, ambulatory blood pressure is blood pressure that's taken while out in the real world. And one reason that is important is because a lot of other work has shown that clinical blood pressure measurements may be subject to the kind of white coat effect, or perhaps to masking. So the white coat effect is when your true blood pressure is not as high as the recording when you're in clinic, or the opposite can happen where your true blood pressure is much higher, but when you go into clinic, you get a relatively low reading. Both of these misrepresent the true blood pressure, and therefore getting a measurement outside of the clinical setting is important for actually being able to assess one's blood pressure levels. It also allows us to assess whether or not a person has what's called sustained hypertension. So that is hypertension that is present both in a clinical setting and in the real world, as assessed via ambulatory blood pressure. So ambulatory blood pressure is a technique, like I said, for capturing blood pressure in the real world. It is essentially done kind of as exhibited in the figure here on the right. So you wear a cuff, and the cuff takes your blood pressure over regular intervals while you are living your regular life. And you're only asked to remove the cuff if showering. So for the Mule study, one of our primary outcomes was 48-hour ambulatory blood pressure. In this study, the regular intervals were 30 minutes during the daytime. So a reading is captured every 30 minutes from 8 a.m. until 9:59 p.m. and then hourly overnight to minimize disruptions to sleep. What we're going to talk about today are, even though these data are captured over 48 hours, we're generally going to talk about these data as modeled as either over 24 hours or by bifurcating to values that were only captured during the daytime. Again, that's 8 a.m. to 10 p.m. and those captured at night, which is 10 p.m. until 8 a.m. And the exposures that we want to talk about today are societal, psychological, and physical. So we said before that blood pressure is responsive to all of these kinds of different stressors or exposures. And since we can't account for a lot of the disparities using traditional risk factors such as socioeconomic status, diet, exercise, we're trying to tease apart whether or not there could be psychological and societal exposures that kind of help explain some of those disparities. So we're going to look at one that asks about primary household financial responsibility. We have a measure of net worth, so how many financial assets one has. We also examine associations between stress due to personal experiences versus stress due to those in your network. The only physical correlate that we're going to talk about today are levels of obesity. And then last, we're going to end with an examination of whether or not blood pressure was affected by possible pandemic stress, or at least the onset of the COVID-19 pandemic, and whether or not that may have been modified by measures of positive affect. So specifically, one of the reasons that we're interested in pandemic stress is these data were the baseline for this study occurred during the years between 2016 and 2019. So as you might imagine, the cohort was scheduled for annual follow-ups. If you came in April of 2019, then that next year you probably wouldn't have been able to be seen. So before we get to all that, I want to start again kind of with the baseline analysis. So the spaghetti plot on your right shows the ambulatory blood pressure recordings for 416 of the women in the study based on whether or not they held primary financial responsibility for their households. So this was assessed in our psychosocial kind of battery with a single item binary scale. It just asks, are you the primary breadwinner? Each line, so the people who were the primary breadwinner are on the right, people who were not are on the left. Each line here represents recordings from one particular participant. And as you can see, it captures that kind of overnight bend that we would expect. Recall that blood pressure should decrease at night and then kind of return to a level, level during the daytime. So our initial kind of approach here was to use the traditional approach for ambulatory blood pressure. So often when you read about ambulatory blood pressure in scientific literature, the outcomes are essentially bifurcated as the average value during daytime or nighttime. So that those are the kind of outcomes that we're going to use for this first set of analyses. So the daytime systolic blood pressure is simply the average taken over those daytime hours. Same thing for nighttime, same thing for diastolic blood pressure. So these analyses that we conducted excluded unemployed women. There were some kind of conceptual issues with being able to provide primary financial responsibility while being unemployed, and the four outcomes that I just described, so that's daytime and nighttime systolic and diastolic blood pressure, are all going to be modeled separately. So if you call each of those kind of BPI, this linear regression equation shows the kind of initial approach where we account for some additional covariates, but our primary interest is in an estimate of beta 1, which is an effect of financial responsibility on blood pressure. And we analyze this model in several stages. So since age is known as one of the primary predictors of blood pressure, our kind of initial model is only adjusted for age. After that, we add in kind of socioeconomic status indicators. Then we account for kind of clinical indicators that could be associated with ambulatory blood pressure. In model 3, we also add on the use of antihypertensive medications. Then in model 4, we account for financial strain, and we also account for whether or not the respondent has, the level of depressive symptoms for each respondent. So the kind of descriptive statistics are given here. You'll see that on average, like we said, the women were between 30 and 45. So on average, they were around 38 years old. Many of them, we actually had to reduce the number of applicants and respondents who had college or higher education. So we have about 50% of the sample with a college education, and that doesn't seem to differ based on financial responsibility. However, the income level obviously does differ based on financial responsibility, where women who have financial responsibility were more likely to be in the lower levels of income as opposed to women who did not have financial responsibility for their household. Similarly, those who had financial responsibility were less likely to be married or have a live-in partner as opposed to those who did not have financial responsibility. They were also more likely to be single parents, and they were also and had slightly smaller family sizes or household sizes. And interestingly enough, we can see just from a raw examination of the blood pressure levels between these two groups that indeed the women with financial responsibility appear to have about a 3.5 millimeter of mercury higher daytime systolic blood pressure. That difference appears to kind of persist when you go from daytime to nighttime. And the same is true with slightly smaller differences when we look at diastolic blood pressure. However, the proportion of women who attested to using antihypertensive medication did not seem to have an association with financial responsibility. So for the actual regression results, I'm here showing the estimated beta value for financial responsibility across all 4 outcomes and all 5 models. Recall again that model 0 only adjusted for age, and then we added on socioeconomic, clinical, and other factors after that. And you can see that that kind of unadjusted difference that we saw in the descriptive statistics is not only consistent, but it's actually exacerbated. Whereas we thought before it was about a 3.5 point difference, here it shows about a 4-point difference between the women who have financial responsibility and those who don't, with financial responsibility being detrimental to causing higher levels of ambulatory blood pressure. So since financial responsibility was one of the values that, was one of the indicators that was associated with higher blood pressure, we started to examine whether or not other kind of non-traditional measures of socioeconomic status might be more suitable to account for disparities in cardiovascular disease amongst African-American women compared to kind of more traditional more traditional socioeconomic status indicators such as income or education. So we used another another single item scale from our psychosocial battery. This one I'm referring to as net worth. So the question asks, suppose you and the others in your household were to sell all of your major possessions, including your home, and turn all of your investments and other assets into cash, and then pay off all of your debts. Would you have something left over? Would you break even, or would you still be in debt? So we use those three categories as an indicator of the participant's net worth, and used a similar kind of modeling strategy to first examine models only adjusted for age, then adding on other socioeconomic status indicators, as well as clinical indicators and depressive symptoms. For this analysis, we also examined associations between net worth and sustained hypertension. Recall that sustained hypertension is hypertension both in clinic and as assessed via ambulatory blood pressure. And the results, specifically, I'm showing the results for daytime systolic blood pressure, showed a substantial difference between the women who would remain negative if they were to sell all of their assets and pay off all their debts, compared to the women who would still have something left over. Specifically, there was nearly a 7.7 millimeter of mercury difference when we only adjusted for age. That difference decreased as we adjusted for additional variables, so that in our fully adjusted model, there was about a 5.5 millimeter of mercury difference between the women who would be in debt and those who would have something left over. You'll also notice that none of the other traditional socioeconomic indicators were significantly associated with daytime blood pressure values. And we had similar findings for nighttime blood pressure, but not for diastolic blood pressure. For nighttime systolic, but not for diastolic blood pressure. So so far we've seen that kind of these non-traditional indicators of socioeconomic status, specifically financial socioeconomic status, have been stronger indicators, or stronger predictors of blood pressure compared to traditional factors such as income and education. But we were interested also in whether or not kind of societal factors might be impacting ambulatory blood pressure. So the next exposure is really a comparison of exposures. So we look at personal stress versus network stress. And by network stress, what I'm referring to is essentially stressful events that occurred in the lives of friends or family. And we wanted to know whether or not those kind of network stressors impact BP blood pressure as strongly as stressors that occurred in the participants' personal lives. So we assessed the stress levels using the stressful life event scale. So this is a 22-item validated scale that essentially asks over 22 kind of situations whether or not this event has occurred in the past 12 months. And if so, how upsetting is that event? So the responses could be, no, this event did not occur. This event occurred, but it wasn't at all upsetting, or this event occurred and still somewhat upset, or it's very upsetting. And the types of events were, so for the personal stressors, we bifurcated these 22 into 15 items for the personal stress subscale and 7 items for the network stress subscale. So the personal items were questions like, or events rather, like you were quit or fired or laid off from a job in the past 12 months, or your partner had an affair in the past 12 months. The network stress subscale included items such as a family member had legal problems or problems with the police, or you had to take on unexpected responsibility for a child that was in your network. So the subscales here, we count up the number of items that were that were attested as at least upsetting or very upsetting and still upsetting. And used, again, a similar modeling strategy. So we examined both daytime and nighttime systolic and diastolic blood pressure, and essentially found that the, daytime, not nighttime blood pressure, and essentially found that the network stressors were much more strongly associated with increased blood pressure than the personal stressors. So, for example, a person who has one network stressor had on average, about a 6 point higher millimeter, 6 millimeters of mercury higher daytime systolic blood pressure compared to one who had no network stressors, as opposed to about a 2 point difference for the women who, had one personal stressor compared to no personal stressors. So far, what we've seen is that a lot of evidence shows that these kind of non-traditional socioeconomic indicators impact the blood pressure amongst Black women at this age much more strongly than the traditional kind of socioeconomic indicators, such as education and income. And those traditional socioeconomic status indicators don't really seem to buffer the cardiovascular disease risk as conferred by blood pressure for this sample. Similarly, stress from family and friends appears to have a larger impact on blood pressure in African American women compared to personal stress. And this actually even persists when we account for the personal stress. So some of the strengths so far of the studies, or the analyses that we talked about. So the recruiting methods were important because they allowed us to obtain a pretty representative sample for Black women living in the Atlanta metro area. And we use clinical research coordinators to actually conduct the psychosocial battery, which minimized missingness and also, I think, allowed for kind of deeper connection and more personal connection between the respondents and the study team. And importantly, the PI is a psychologist, and so she came up with a broad range of psychosocial stressors that we account for. However, all of the analyses that I've talked about so far are cross-sectional. So we only use the baseline data in each of these analyses. You might imagine as well that the generalizability is going to be severely limited, right? We only have a certain age range and they are captured in a certain geographic area. And importantly, the very first picture that I showed, the very first graph that I showed rather, was the spaghetti plot that showed how variable these blood pressure measures can be over time. So when we take the average of those, we're likely to kind of obscure some of that variability. And we're actually discarding a lot of that variability, which may lead to a loss of statistical power. And we also assume consistent rest and active periods across all participants, since we bifurcated at 8 a.m. and 10 p.m. time points. And this may misrepresent specifically for the nighttime, taking the average may misrepresent the nighttime blood pressure due to, if we have an uneven increase and decrease over that time period. So for example, this is the observed blood pressure from 48 hours as overlaid onto a 24-hour time scale for one participant. And you can see that we capture that overnight kind of dipping, but we don't know whether or not taking the average of this overnight dipping is really going to be a good representative of what's happening during that time period. And you can see again that the same is true for all participants. So we decided to use an updated statistical approach in subsequent analyses. where we employ generalized additive models. So a generalized additive model is a specific technique that can kind of be associated with functional data analysis, although they use slightly different notations. So essentially, generalized additive model can be written as a linear regression with a nonlinear term f of t, or f added onto that usual linear regression. So this function f is will allow for nonlinear relationships between some predictor. In this case, I'm calling that predictor t, and the outcome of interest. And there are lots of very flexible data-driven approaches to find the kind of best functions. What we use are cyclic cubic splines. So this requires a choice of kind of different possible basis functions to be able to build up that unknown function. And it's very useful for modeling time series data and other types of functional data. So data where we can assume that the observed value for each participant is a function, or where we may assume that there's a nonlinear association between the exposure of interest and the outcome of interest. And lucky for us, there was already a lot of extensions for this kind of model already available. So we actually employed the generalized additive mixed effects model, which essentially is an extension for non-IID data. And one of the things that I like about this kind of approach the most is that it allows for these model-based visualizations that allow us to compare it to the raw data. So as shown here. So this is a generalized additive model fit for a single participant. And essentially it shows that we can capture a lot of that nonlinear relationship between time and blood pressure, whereas taking the average may not really get at a lot of the variability that's inherent in these data. For a full sample model, we actually just add on one subject-specific, random intercept. So you just take the same model, expand it by adding on a subject-specific random intercept. And here I'm showing the kind of estimated time courses or blood pressure profiles with blood pressure curves is stratified by BMI class, where we group together women with normal and overweight and women with class 1 or class 2 obesity. So the results from this updated analysis were recently published in Obesity. And what we were able to find is that the women with class 3 obesity had a markedly different markedly different time courses, blood pressure time courses overnight compared to the women who had normal weight or class 1 or class 2 obesity. Specifically, if you look at the difference as shown in the bottom row between time courses of women with normal weight and those with class 1 or class 2 obesity, it essentially shows that the difference over the entire 24 hours was flat. As opposed to when we examine differences between women with class 3 obesity and those with another BMI, we see that the difference has this kind of hump overnight. So for the women with class 1 and class 2 obesity, that overnight hump gets up to maybe around 5 millimeters of mercury. And for women with normal weight or overweight, it gets up to nearly 10 millimeters of mercury overnight, which is strikingly different from what we were able to find when in an analysis that uses the traditional approach as we saw in the previous 3 analyses. So what we found was that kind of using this updated approach that takes advantage of more of the data allowed us to uncover granularities about the differences between those groups that were simply unavailable using traditional methods. Specifically, we wrote about how the systolic blood pressure of women with class 3 obesity decreased a lot more slowly compared to the women with other BMI categories. And they reached their overnight minimum at a much later time than the other women as well, which may be associated with additional cardiovascular disease risk, as often cardiovascular events occur in the morning. And many kind of cardiovascular scientists think that that is due to what's called the morning blood pressure surge. So it decreases at night. When you wake up, there's a kind of surge, or right before one wakes up, there's a surge in the blood pressure so that it can get back to those daytime levels. Seeing that the women who with class 3 obesity reach that minimum at a much later time means that they would have to have a quicker surge, or possibly have a quicker surge, in order to get back to their daytime level. And the use of this functional data approach also facilitated this model-based visualization of these very complex data, which allowed us to be able to kind of really speak to the differences in between those groups. However, again, all of the analyses that we've talked about so far are cross-sectional, so we really can't say anything about causality. And we also derive these 24-hour curves using 48-hour data. So there could be some kind of double dipping going on there. However, we're thinking about extending, and there are also additional sources of variability that could be present, right? So for example, while we overlay the 48-hour data onto one day, there may be external stimuli that were present in one day that were not present in another day. And right now we don't account for that. And similarly, we don't account for individual sleep or rest, but the kind of functional approach should account for that automatically, in that we're simply looking at the time course and not delineating the time at which one is considered to be sleep or resting. So the next set of analyses that I want to talk about are preliminary. So this is an ongoing analysis that I'm conducting, and it essentially asks whether or not the longitudinal changes in ambulatory blood pressure may have been affected by the COVID-19 pandemic. So there's been evidence of at least one study, and this was in a Japanese population, that found clinic blood pressure increased by about 1 to 2 millimeters of mercury during the height of the pandemic in 2020, compared to prior years where the annual increase was tended to be less than 1 millimeter of mercury. So we decided to examine whether or not changes in daytime and nighttime blood pressure, so this is back to those averages, before the COVID-19 pandemic may have been different from those since the pandemic, and whether or not those changes may have been modified by baseline levels of positive affect. So like I said a moment ago, now we're going back to the kind of averages, so throwing away a lot of that inherent variability. And we are using the date of the shutdown in Georgia, March 13th, to delineate whether or not readings occurred prior to COVID, before March 13th, 2020, or post-COVID, after March 13th, 2020. Because of the disruptions due to COVID, the follow-up times are going to be calculated as the difference in years between visits and the baseline date. And you'll see why that is in a moment. The exposures of interest, like I said, we're really interested in whether or not the occurrence of the COVID pandemic is the primary exposure, but we're also interested in whether or not the changes may have been modified or moderated by measures of positive affect. So specifically, we considered environmental mastery, purpose in life, and resilience. And each of these are measured in the psychosocial battery that I kind of keep coming back to. So we looked at purpose in life, and we looked at resilience and didn't find much there. So the rest of the talk, I'm going to focus on the primary exposure of interest is environmental mastery. Environmental mastery in this study is measured with the 14-item subscale of Riff's psychological well-being scale. So I think that's like a 28-item scale, and we take 14 of those and call those, add them up to get environmental mastery. So the responses for each of those 14 items are Likert type scales that we have anchored at 0 rather than 1, so that the sum of scores of all across all 14 will range from 0 to 80, with 0 indicating no sense of environmental mastery and 80 indicating a perfect sense of environmental mastery. So some of the kind of the items on this are one of the items is given by is given here. It says, my daily life is busy, but I derive a sense of satisfaction from keeping up with everything. And the possible responses are strongly disagree up to strongly agree. The current analysis uses a median split for these for this score. So we found the median to be 50, and we call women with environmental mastery score who less than 50. We say that they have less mastery. Score of 50 or greater indicates more mastery. So I said a moment ago that you would see kind of the difference, or excuse me, why we want to consider follow-up time as numeric as opposed to, or continuous as opposed to categorical, since it was supposed to be annual follow-ups. And this kind of spaghetti plot aims to exhibit why that is the case. So the circles on the left, the graphs on the left show daytime systolic and nighttime in the top, and nighttime systolic blood pressure in the bottom, over the actual dates at which these values were captured. So the circles indicate a baseline visit, the triangle indicates a visit 2, and the plus indicates visit 3. And you can see the kind of the huge cutoff that occurred at in March of 2020, right? Where we all of a sudden don't have people coming back. If you look at this, instead of based on the calendar date, based on the time of follow-up, you can see that for visit 2, most of the people came back right at 1 year. Recall the initial visit, people came between December of 2016 and April of 2019. So a lot of people that came, before April or March of 2019 for their initial visit were able to come back about a year later. However, as we get further out, you can see that the differences in time and follow-up time varied a lot. On average, people had, I think, about a 4-year follow-up time for their third visit, which was supposed to be 2 years after the initial visit. And you can also see at least one triangle out here that indicates someone's quote-unquote visit 2, which was supposed to be 1 year after baseline, was actually about 4 years after baseline. And another person's was more than 6 years after baseline. And the same thing is true. So we can see this kind of exhibited as well for diastolic blood pressure. So the descriptive statistics, I'm showing the descriptive statistics here as stratified by baseline levels of mastery, where we have 410 women in this study. So all of the baseline visits, like we said, occurred pre-COVID, and of those 414 women who had ambulatory blood pressure, 369 also came back for visit 2, and 337 came back for a third visit. The median follow-up time for the second visit was about 1.3 years, which is about expected because, again, most of the baseline visits occurred in 2017 and 2018. So that about 93% of those were occurred pre-COVID. As opposed to the third visit, the average follow-up time, which was supposed to be 2 years, actually was 3.9 years, with only about a quarter of those occurring pre-COVID. Oh, and I also highlighted in black here the covariates that were associated with the levels of environmental mastery, or excuse me, with the median split of environmental mastery. So the women who had more mastery tended to be a little bit older, about a year older than the women who felt less mastery. Their measures of resilience were also, and purpose in life were also higher, which is expected. And the women with more mastery also had a substantially less average number of depressive symptoms compared to the women with more mastery. Education was also associated with mastery, where the women with more mastery were more likely to have a college or a higher college degree or more education. So we went back to like we said before, went back to these kind of summary measures as the outcomes. However, this time, since we have longitudinal data, we are employing a linear mixed model to examine the associations between our exposures of interest, again, COVID-19 and mastery, and daytime and nighttime systolic and diastolic blood pressures separately. Our initial model here, again, we model all four values separately, and the independent variables of interest are going to be time to follow up, environmental mastery, again, that's below the median versus above the median. And we also account for age at baseline, the month that the ambulatory blood pressure monitoring occurred, because blood pressure is also seasonal. And so whether or not it's cold outside or hot outside is associated with blood pressure levels. And we also adjust for COVID time. So we initially tried a three-way interaction between time to follow up, mastery, and COVID time, and found that there was not really an association there. So most of the remainder here really focuses on associations between environmental mastery and ambulatory blood pressure as opposed to COVID time. So we did not see kind of similar increase in the rate of increase for our sample as was shown in the Japanese population. To account for the interperson correlation, we also included a subject-specific random effects, random slopes, as well as subject-specific random intercepts, as well as random time slopes with unstructured covariance. And we use random time slopes because, as you can see here, there's a lot of variation between each woman's kind of trajectory over time. Right. So our initial model only adjusted for these kind of model zero, adjusted for these kind of minimal covariates, so age, month, for seasonality, so on and so forth. We then added on the clinical covariates, so BMI, as we already know, is strongly associated with ABP, whether or not you smoke, and use of antihypertensive medications, as well as depressive symptoms. Then to examine whether or not associations remain, we also added on kind of the traditional socioeconomic status indicators, so education, income, employment, and family size. And none of these are time varying. We only account for covariates as assessed at baseline. And the results show that only nighttime systolic blood pressure was moderately associated with the interaction between mastery and time, so that it's the kind of opposite of what we expected. The women with higher environmental mastery seem to have a higher rate of increase over time at about 1.4 millimeters of mercury per year, as opposed to women with lower levels of mastery whose annual increase was about 0.82 millimeters of mercury per year. This is important, especially because I kind of hinted at before, nighttime systolic blood pressure is one of the primary indicators for increased risk for cardiovascular disease. However, you can see that the women with more mastery also had a slightly lower nighttime blood pressure at baseline compared to the women with more mastery. So essentially what this ended up showing was that the kind of protective effect that was conferred on the women with higher mastery appeared to wane over time. So over that 4 to 6 year period, the blood pressure of the women with lower mastery didn't change much, but for the women with higher mastery, it increased to a level to meet the women with lower mastery. However, some additional modeling is really going to be necessary to confirm these results. There are lots of outliers, especially in both the blood pressure levels as well as the levels of mastery. I think one woman attested to a mastery level of 8, which is essentially no mastery at all. And of course, we cannot really one of the limitations is that we didn't use time varying covariates, so it's hard to assess whether or not changes in these exposures are going to be associated with the kind of longitudinal changes that we've seen so far. And we also went back to the summary measures, and so we are discarding a lot of that inherent variability that is probably going to be useful for actually teasing out these associations. And like we said before, generalizability is also an issue here since it's limited to a specific time, age range, and geographical region. So what I'm hoping to do is kind of employ that functional data analytic approach or a similar functional data analytic approach to see whether or not using more of the data as observed might give us more statistical power to be able to tease out the associations over time. And I'm also planning to kind of go back to my neuroscience data integration roots. And we have a sub-study from this cohort of women who came to visit too. They had MRI scans done and fMRI scans done. And so I'm currently working with a colleague to examine whether or not we can tease out what cardiovascular, both clinical and subclinical cardiovascular, blood pressure measures are associated with connectivity in the brain or brain morphometry measures. And I'm also hoping to examine the longitudinal associations between these blood pressure measures and other subclinical cardiovascular health measures. So this study also conducts pulse wave analysis, which allows us to be able to estimate a person's central blood pressure, which is blood pressure more likely to be experienced by the heart and brain, and therefore more likely to be associated with those adverse outcomes, as opposed to peripheral blood pressure, which is a good indicator and easier to obtain, but may not be as strong of a predictor. And we also have carotid intima media thickness. So that's a measure of the kind of thickness or possible inflammation in the carotid artery. And I'm hoping to be able to examine associations between these subclinical measures over time. So I want to make sure that I acknowledge the PI, Dr. Tanae Lewis, again, excellent collaborator. She's been a mentor of mine for several years now. The Muse participants all, allowed us to batter them with psychological and sociological questions for hours at a time, and then went home to wear their cuff, which is very irritating. The research coordinators who worked tirelessly to make sure we actually obtain that data and are respectful to our participants, as well as my collaborative study team, many of whom I've published several papers with, and the NHLBI who funded this study. And here are some of the papers that we recently published out of this study. Does anybody have any questions?
Thank you very much. Any questions in the room or online?
So I have one. I was trying to put together the first two sets of results that you presented. The first one where you had the summary average, I guess, in daytime and nighttime. I thought and I can't remember exactly how many, but the nighttime results did not show an effect of your what was your exposure at that time?
I think you're the network stressors versus personal stressors.
Yeah, okay. So then so you saw an effect during the day but not at night, correct?
Yeah. Yep.
So meaning at night people slept kind of equally or something, or you're stressed. Did it mean you were more stressed during the day because you're awake and aware of it, and when you're asleep you're not subconsciously stressed? But then I guess what I was trying to put together was with the next set of results, it was actually the nighttime effect that you found. But I guess that was in the obesity group.
Yeah. Yeah, so that's a really good question. And honestly, I'm not really sure why we would have seen usually when we see associations, the nighttime blood pressure tends to be the one that is most strongly associated. And I hadn't really thought about why we wouldn't see an association there.
Oh, okay.
Maybe a little bit of a follow-up to that with all your results, the linear, the averages of daytime versus nighttime, and then also the general additive models. Did you ever look at sort of the overall variability explained by the models and the partial R squared for the different variables, and was that interesting, and how much of the variability was explained? And
yeah. So unfortunately, not very much of the variability is explained. In our functional models, I think we explained about 17% of the total variability. And in the linear models, it was closer to about 10%. So clearly, we are missing a lot of variability, which is why I, ought to include the subject-specific time slopes in the longitudinal analysis. And that is a project that I'm actually working on with my PhD advisee, where we are examining kind of GAM location and scale models, so that we're examining whether or not time-specific variability can account for more of that variability over time.
Okay, great.
I had a question about, I think it was maybe the second project looking at the personal stressors versus the network stressor. And I was surprised by the results that you saw a bigger impact of the stressors in the network than for individual, their personal stress. And I was wondering if there was an interpreting the magnitude of the effect estimates. Is there anything to think about more deeply? And that I think the network stressors maybe was like a 7-item scale, or there were like 7 questions that went into it. And in the personal one, I think there was 15 questions or something. I was wondering if, like, does a 1 unit change mean the same thing? Because one of them,
that's a great question. So for these, we average the responses rather than summing them up, and so we are assuming that they kind of do mean the same thing. Or excuse me, no, that's false. We added the number of items that were more stressful. However, what we found was that even when we account for, so model 5 adjusts for network stressors too. So even when we account for the personal stressors, the network stressors are still much more strongly associated. In fact, in this model that included both sets of stressors, personal stressors were not significantly associated with the outcome.
Wow. Okay, thank you.
Yeah.
Did you ever look at interaction between the stressors?
That's a good question, and I don't recall. We published this about 2 years ago, and I should go back and look at that.
Any other questions? All right, if not, let's thank the speaker again. Thank you very much.
Thank you, guys.